بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضة لغات، أهلا بكم. النهاردة هناخد مراجعة جديدة في الديناميكا. طبعا احنا عارفين الفرق بين علم الديناميكا وعلم الاستاتيكا. علم الديناميكا هي علم الحركة، طبعا قوانين نيوتن موجودة معانا، وازاي تعرف تجيب السرعة من المسافة، وازاي طبعا في حاجات جديدة درسناها السنة دي في الديناميكا عن طريق التفاضل والتكامل لبعض القوة، على اساس ان تقدر تجيب الاكسلريشن اللي هي الجاذبية عن طريق الفيلوسيتي السرعة، وازاي تقدر تجيب الفيلوسيتي من الديستانت، وازاي تجيب الديستانت من الفيلوسيتي. دي مهمة جدا جدا، قوانين very important rules in dynamic. Welcome my dear student in our math program for second 3. Today we are taking new lesson in dynamic. It's titled Revision in Dynamic. Look at the first example. Body of mass 400 gram is projected vertically upward with velocity 25 meter per second. Dear student, what is the velocity? Initial velocity. Body of mass 400 gram is projected vertically upward with velocity 25 meter per second. What is its kinetic energy when it becomes at height 15 meters from the point of projection? Look at the solution. Dear student, look at the position of the motion up from down to up, the distance 15 meters. Consider C is unit vector in vertical direction upwards. Dear student, we know that kinetic energy T minus TO or T minus T naught equal the work. T minus TO equal negative mg times S. Negative mg times S, this is the work. Then T minus half times 0.4 times 25 square equal 0, negative 0.4 times 9.8 times 15. By using simplify, find the value of T is 66.2 joule. Another example. We have another solution to this example. Since the third rule of motion, V squared equals V naught squared plus 2GS. By using V naught, initial velocity 25, G 9.8, distance S 15. By using the negative Y because the motion up, then we find the value of V squared by using simplify 331, then the velocity T equals half mv squared, kinetic energy. What is the rule? Excellent student. Half mv squared. By substitution, about m 0.4 and about v 331 power 2, then 331, answer is 66.2 joule. Then we find the kinetic energy by two rules. The first rule, T minus T naught equals the work. Find the work, and by using the work, find the value of kinetic energy, or a change of the kinetic energy equal the work. The work done equal change of the kinetic energy. T minus T naught is change of kinetic energy equals the work done. Then by using the rule of kinetic energy equal half mv squared, by using substitution m equal 0.4 and v squared 331, then the kinetic energy equals 66.2 joule. Another example. Dear student, look at the curve between the distance and the time. Number 1, VA from 0 to 3 equals difference between distant final minus ST initial over T2 minus T1. Look at a new direction. Negative 2 minus 0 over 3 minus 0 unit vector equals negative 2 over 3 unit vector. What is the VA? Equals 2/3 meter per second. VA from 0 to 1 by the same method, 4 minus 0 over 1 minus 0 equals 4A accelerated. Why? Because more than 0. From 0 to half, 2 over half equals 4. V initial, 2 over 1 over 2 equals 4. Another example. A car of mass 1.96 ton moves on a horizontal road with uniform acceleration at an instant. Then its velocity became 90 km per hour after covering a distance 50 meters. If the resistance to the motion equals 400 kilogram watt, calculate the force of the engine of the car. Dear student, if the resistance to motion equals 400 kilogram watt, the required the force of engine of this car when the resistance became 400 kilogram watt. Solution. Look at the motion of the car. Let's see its unit vector in direction of motion. V naught equals 18 multiply 5 over 18. We convert to meter per second. Answer is V naught 5 meter per second. V equals 90. We change or convert 90 to meter per second also. Then the final velocity is 25 meter per second. We have initial velocity 5 meter per second of this car and final velocity 25 meter per second. Since change of kinetic energy equal the work done, T minus T naught equals W. Then we have half mv squared minus v naught squared equals the work done equals F minus R times distance S. By using substitution, then left hand side is half times 1960 times 25 squared minus 5 squared equal F minus 400 times 9.8 times 50. It's easy to find the value of F. The force F minus 400 equals 1200 kilogram watt. Then the force of engine is 1600 kilogram watt. Another example. Body of mass 2 kilogram moves with uniform velocity of magnitude 3 root 10 meter per second. Dear student, we have body of mass 2 kilogram moves with uniform velocity. What do you mean uniform velocity? X student moves equal distance time distance. Body of mass 2 kilogram moves with uniform velocity of magnitude 3 root 10 meter per second. resistance force of magnitude 6x power 2 Newton, where x is displacement, which the body covers under the action of the resistance meter act on it. Dear student, remember, resistance force of magnitude 6x squared Newton, where x is displacement, which the body moves under the action of resistance meter act on it. Find the velocity of the body and kinetic energy when x equal 3. Solution. We know that the work done equals integration from 0 to 3 f ds. By using integration, find the value negative 54 joule. Since kinetic change of kinetic energy equal work done, by using the rule, then find the velocity is equals what? V squared 36, and then V equals 6 meter per second. Therefore, T equal half mv squared, equal half times 2 times 6 squared equals 36 joule. Another example. Body moves in straight line under the action parallel force to this straight line F equal to S plus 1, where S is distance between the body and constant point O on this straight line. Find the work done by this force from S equals 3 to S equals 5. Solution. The work done, dear student, from S equals 3 to S equals 5 equals integration of the force respect to ds. Then the work done equals integration from A to B f ds by substitution about A equal 3, about B equal 5. What is the f? Equal 2s plus 1 ds. What is the integration of ds? Excellent student. 2s squared over 2 equal s squared plus integration of the 1 is s from 3 to 5 equal 30 minus 12 equal 18 joule. Then the work done equal integration of the force respect to ds. Dear student, we know that change of kinetic energy equals the work done. In this example, we have force. This force is a relation by S. What is S? Is displacement or distance. The work done in this case equals integration from interval S1 to S2 or from A to B for the force respect to ds by substitution about F by 2s plus 1, then find integration from 3 to 5. What is the integration, dear student, of 2s? 2s squared over 2. What is the integration of 1? Is s. Then the integration becomes s squared plus s. After that, dear student, we substitution about s equals 5 and about s equal 3, then subtract the first minus second, we find the work done. Remember, the work done is very important. We have two rules in work done. Change of kinetic energy equals the work done. Also, work done equals integration of the force respect to ds. Dear student, look at another example. This example, dear student, is very important also. Body move in straight line such that the acceleration of its motion A is given as function of the time t by the relation A equals 2t minus 6, where A is measured in meter per second square unit and time t in second. What is required? Calculate the momentum of the body. Momentum of the body in the time interval t more than or equal 3, smaller than or equal 5 if the mass of the body is 8 kilogram. Solution. The momentum dh equals k constant integration of t1 t2 or from a t1 to t2 acceleration respect to time t. Momentum, dear student, its symbol delta h equals constant k multiply integration of a acceleration respect to time t from t1 to t2. What is the acceleration? This is t2 minus 6. We know that acceleration A is what? Is a function of t. What is the acceleration? 2t minus 6. K equal 8. Integration from 3 to 5. Definite integration. Then what is the integration of 2t minus 6 equal t squared minus 5t, 3 to 5, 6t from 3 to 5. By substitution equals 32 kilogram meter per second. Another example. A stone is projected vertically upwards and its height x after t second from the projection is given by the relation x is equals 49t minus 4.9 t square, where x is in meter. Find maximum height of the projected body can reach. Remember, maximum height means velocity equals 0. Excellent, student. Number B, find algebraic of the velocity vector when stone is 78.4 meter height, then find its velocity. Remember, the second required, find algebraic of velocity vector when stone or when its distance 78.5 meter high. After that, we find its velocity. After graph both the position time graph and use them to analyze the motion. Solution. Dear student, since xt equals 49t minus 4.9 t square, this is relation between the distance x respect to time t, x function at t. xt equals 49t minus 4.9t square. Since vt equals, what is the velocity? X and student, differentiation of displacement respect to time t. Vt equals dx over dt. By using differentiation, 49 minus 9.8t is the velocity vt. Then, don't forget, dear student, integration of velocity is displacement, but differentiation of displacement is velocity. The stone reach at maximum height when v equals what? X and student, v equals 0. When stone reach the maximum height, then the velocity must be, final velocity must be equal 0. Then by using the velocity equals 0 to find the value of t, in this case 49 minus 4.8 t equals 0, then the time t is 1.1 second. What you mean? the stone when t equals 1.1, the maximum height, the body was maximum height and its velocity equal 0. Then the maximum height at t equals 5 by using 49 times 5 minus 4.9 times 5 square equals 122.5 meter. The stone is 78.4 meter high when x equal 78.4, means high equal x. Then by using the first equation, x equals 78.4, we have quadratic equation in time t. Then 4.9 t squared minus 49t plus 78.4 equals 0 by using factorization. Before 4.5 divided by each one 4.9, 10 squared minus 10t, t squared minus 10t plus 16 equals 0. We know that t equals 4 and 6, 2 and 8. 2 times 8 equals 16, sum equals 10, t equals 8. Also t equals 2. We have 2 types. Therefore, we find the velocity at 2 by using t equals 2. 49 minus 9.8 times 2, answer is 29.4 meter per second. This is the velocity when t equals 2. When t equals 8, by substitution about t equals 8, answer is negative 29.4 meter per second. The stone is 78.4 meter once ascending after 2 seconds and once descending after 8 seconds. Why? Because the velocity is negative in 8 seconds, positive in 2 seconds. Means ascending at 2, descending at 8. This velocity. Algebraic measure of the velocity is 29.4 or negative 29.4. The velocity of a stone of the two cases, norm of positive or negative 29.4 means 29.4 meter per second. From the position time graph, we find that, look at xt and t. T time 1, 2, 3, 2, 10, and the displacement or the distance xt from 0 to 117.6. When the stone reaches the maximum height, look at the maximum height, 122.5 meter at t equals 5. Look at the point 5 and 122.5 t. When t equals 5, the stone reaches the maximum height 122.5 from the graph or the vertex of the curve 5 and 122.5. The stone gets back to the projection point once again when t equals 10. 10. T equals 10, x equals 0. Then the stone gets back to the projection point once again when t equals 10. Ascending stage took 5 seconds. Ascending stage took 5 seconds. Descending stage took another 5 seconds. We have 10 seconds. Ascending from 0 to 5, the body ascending From 5 to 10, this is stage, took or descending stage after 5 or another 5 seconds. The stone was is 78.4 at meter when t equals what? 2 seconds. Look at when t equals 2, the point is on the curve 78.4. T equals 2 seconds and t equals 8 seconds. Another example. Two bodies of mass m and 700 grams, where m more than 700 are connected as the two ends of a light string passing over smooth poly such that the two parts of the string are vertical. The system start motion from rest. What you mean? Initial velocity 0. The pressure on the poly is 100 gram wet. Find m. Solution. Look at the opposite graph. We have two bodies, 700 and m. The motion is 700 g minus t equals 700 a. The mass of the first body 700, equation mg minus t equal ma. What is the m? 700 times g minus t equals 700a. This is the first motion. Then 700 times 980 is the value of g minus 400 times 980 equals 700a. We find acceleration by 300 times 980 over 700. Answer is acceleration 420 centimeter per second square. Then the acceleration is 420 centimeter per second square. Dear student, by the end of the lesson, we know dynamic science is very important in our life. In our life, in home, in street, in sky, in the land, we use dynamic rules. Dear student, I am very happy to spend such time with you. Then don't forget math simple reduce. Welcome in final revision. Goodbye.